Hello, hello. How's it going, everybody? If you can't gather from the chat, I think it still shows up there. I didn't have electricity last week. Fun times. Yeah, went out that morning and it ended up coming back later in the day, but it wasn't happening. So we pushed it to this week. Interesting. It doesn't show. I wonder if it's like a timing thing. But yeah, Cookling today. We have on stream looked at this API or this language, syntax, project, whatever you want to call it, for a handful of streams now, I think. But we've also like pulled it up and mused about it. At least I know I have in my own personal time off stream for years now. And the idea behind Cooklang is that it gives some sort of like spec or syntax that is pretty close to writing out word for word a recipe, as in the thing that you cook to make food, not recipe as in like a programming pattern or anything. And then with that, you parse it. You can generate ingredients lists. And then once you have a concept of an ingredient with appropriate measurements plus steps, there's a bunch of fun things you can kind of do off of that. Make like shopping lists. I'll probably end up, when the stuff we're potentially working on today lands, put that on my personal website. We have a recipes page on my personal website for quite a while now. That's actually coming out of Airtable, but I kind of want to move out of that. I don't love the infrastructure there, that setup. But specifically today, what we're going to do is, in previous streams and talking within the Discord, we have an idea of what we want the API to look like and the things that we want it to do. There's some work done already to enable the playground. They have like a programmatic playground where you can write a recipe on one side and see how it parses on the right side. So there's code that is there. My phone just fell over. There's code that is there, and there's code that works. Okay, I bumped something else when I was doing. All right, we're good. I distracted myself. Things falling and buttons clicking. There's code that's there that works and renders and parses and renders a recipe. Most of that work is actually done in a Rust based parser. So the little bit of integration that ends up landing in JavaScript is taking all of that work in Rust, converting it into WASM, and then using that WASM, like the functions that come out of it or that you can import out of it, using those functions to then do things in JavaScript. It's neat you can do that, and it's great to have a core piece. The downside of that is that the WASM that comes out isn't very JavaScript-y. So we'll talk about that, and we'll potentially shift things around a little bit. But doing a little bit more of the API surface in JavaScript itself means we can work out the ergonomics a little bit more, and sort of like back into then the functions that we need to specifically use and pull out of the Rust-based parser. So that's kind of what we're going to do today. The expectation is that we get some tests and sort of like a shell that's what I'm going to shoot for today. We don't, like functionality wise, we're going to have to wire stuff up. But if I can get like a new export that's starting to head in the direction we want to go, we can come back and fill in the gaps in further PRs or whatever. But this will give us like a place where we can start building on top of, like work out the foundation, get a good idea of what we want it to look like, write a couple like core tests, just sort of give a good feedback loop, and then we can build on top of that. So we're going to drop over here. I want to, let's see. Whoa, what? Did I think I did, what did I do with, I bumped something and it like refreshed and it said it wasn't live anymore. But it's like, it looks like it is. Very weird. Very weird. I don't know why it did that. I wanted to make sure that I accidentally didn't disconnect, but I think we're good. Okay. So, let's do a little to-do list here. We want to look at the WASM bits that we have. We have a little tiny test suite right now, and it's mostly just a test suite to ensure that the type, oh, my key popped off. What is going on here? I am having like all these random issues. What the heck? Okay. It's low profiles. I might have just like, is that one just like, it feels like it's sticking out extra. It's kind of weird. I wonder. I see. Okay. Brief aside. I put these spacers in. So keycap. It's a low profile, so it's not your typical like. It's not these type of keys where they're tall. They were clicky in a non-satisfying way. So I had these stoppers. I don't know if you'll be able to see it. There was two of them squished together. So I accidentally put two of them in there. That's why that key was sitting extra high. And that's why it popped off. All right. Much better. Got it. We are good to go. Okay. To-do list. We're gonna look at the WASM bits, and I think we're mostly. I think we've mostly grouped things in a single class in Rust. We've talked about that a little bit in the past, like on previous streams on this topic. But we'll come back to that and see exactly what's there. And then I think we want to, it's likely either going to be an object or a class, but we'll say start up the foundation, and we'll talk through that a little bit. And then, we kind of have a little bit of something already, but start up a little bit more of a foundation in JavaScript directly. And then wire up some tests. I do have a bunch of issues. In part of these, we'll probably go back through those issues to see the the items that we specifically thought we like the to-do items that we thought would be appropriate to actually have in the API. So we'll check into that to make sure that we're kind of covering those cases. And we'll see where we're at from there. Hey, Chubb, good to see you. All right. So I have. Oh no, that's not what I want to open. I want to close that. I have a new profile. I've been trying to. I feel like VS Code keeps adding all this stuff, and depending on work stuff, they end up saying, hey, you need to install this plugin or you need to have this extension to run such and such. I don't need that extension for everything. And I was like conditionally turning them off, and it was just getting a lot to manage. So I've actually spun up and I have multiple profiles now. Hi, kitty. You want to come say hi? Not yet. So we have a separate profile now for streaming. And that will mean that I can slim down to just the things that we mostly do on stream and care about on stream, and that will be lovely. All right, so we have a package.json and a package.lock. This is npm. I'm going to install npm just to make sure we are on the latest. I don't think there's been too much in the TypeScript role, but we'll go ahead and do that just in case. Maybe. Yeah, come up and say hi. You can come up right now. It's yeah, okay. With this other keyboard, you can see my keys in this corner. With this keyboard, which is, I mean, honestly, probably a good thing. But I tend to sit a little bit closer to. Yes, hi. Okay. Tail down. I tend to sit a little bit closer to the table, which means she's got less room to sit, and it makes it uncomfortable for both of us. Put the tail down. Yes, I know. Put the tail down. Okay, yeah. Hi. Oh my goodness. All right, this cat sometimes, I swear. Okay. So we what were we doing? Slightly distracted by said cat. We were looking at the WASM bits. It's less specifically the WASM bits and more the Rust that we end up using to generate said WASM bits. So in our TypeScript package, we have we've got a bunch of helpers and such, and it is currently using WASMPack. WASMPack it sees some attention, probably not as much as it feels like a very key tool in the ecosystem that it would be nice if it received more attention, but bandwidth and issues, I get it. I don't know if we want to keep it installed in through npm. I'm not hard set on that. I think potentially we could include it in I believe Cargo actually has the ability to add it now. Let's not get too distracted. That's going to be a stretch goal. WASM, pack, and Cargo. Let's give that a quick peek if we end up having time. So we we have this build RS. Not doing too much. Mostly it's injecting this git version function. the bulk of what we care about actually is in this parser. So there's this impl and a render function. The render function does it's generating HTML, and I mean it's probably fine. Honestly, I don't hate it. Does it support other languages? So Cooklang in general is like at its core, it's kind of a specification. This is what the syntax should be like. Then from there, it doesn't have like a strong core of, I don't want to say it that way. It's not like it's missing a strong core of developers, but it was a thing that was defined via a spec, and then folks just sort of like organically did the stuff that they wanted and implemented how they wanted to use it. So I don't know if it was originally created in TypeScript or if like the original parser was in TypeScript, but at this point, like most of the work for the people that have been involved the longest or have been putting in the most effort, they're doing it in Rust. So part of it was, if we have a single parser, it's easier to make sure that, like, if you build on top of a single parser, it's easier to ensure that everything's building off the same like foundation. So a spec is in some ways a foundation. You can build everything off of that. But it means that if you have multiple implementations in multiple languages, everyone needs to update every time the spec updates. Long story short, Rust is kind of convenient because you can write the parser in Rust. It has a lot of nice tooling for that, and it's fast. But then you can generate bindings. And WASM. So there's this bindings which uses UniFFI, I think is how you would say it. Oh, me being English first and everything written in English, I haven't honestly like dug into it deeply. I think it does though, because like at the base of it, it's just words and then special syntax. The special syntax, I don't know what it all specifically supports, but when it comes down to it, we have effectively like two ways to measure things ish. There's like the imperial way to measure things, and then there's the metric. Then you get a little bit of the like, is it liquid versus a solid, et cetera, and then blah, blah, blah. But so mostly what it's doing is it's parsing specific syntax, pulling that syntax out into a list of ingredients, and that bit that it does need to parse, it needs to understand the unit of measurement. So like those are the pieces that potentially might have more like language considerations. Everything else in between doesn't really matter, honestly. So here, let's see if we can go to let's see, Playground, Cooklang, this here, Playground. So like, this is an ingredient, but honestly, like, I think it can be anything. So what is let's see. If you have like a recipe, I know that other people have tried other languages because they've tried to do the translation. I saw somebody mention that they tried to do a version of it in a different language, and it works surprisingly well. Surprising for them. So I know it has some semblance of being able to work in other languages. because I think here, let's do I don't know how to like search for, because if I say Spanish recipes, that's gonna turn up like, you know, how to cook the thing. Well, let's just try it. We'll do like if I search for Italian pasta, uh, pasta recipes Italian, like that's just gonna give me Italian recipes, right? Because like my language here is set to English. I wonder if they've got no, that's to use it. They had a ooh, here we go. Cooklang recipes. So this is folks have added their recipe list here. Most of them are repo with recipes written in Cooklang. I don't actually see. I think, okay, this person might not be. Oh, no, never mind. Yes, I think the answer is yes. I don't have a good example. So if you have a recipe in a different language, we could give it a shot real quick. Or go ahead and go here and try to drop it in. Let me know. I'm pretty certain it does, but I don't know to what extent. And I'm curious, honestly. Okay, so that being said, it's this working on this is weird because recipes and recipes and language ends up being a word that sort of is cross-functional in this space. Recipe could mean a pattern in programming, or it could be a thing you follow to make food. A language could be referring to the syntax of cook language. It could also just mean English, French, or Italian. All right. So we want to look at the WASM bits. We've got there's this bindings, which is cool. If you're interested in other languages, give that language as in like the programming thing. You don't know all the vegetables in any of the four. That's actually pretty amusing. Yes, hi. Come on up. Come on. Well, then I'm sure you get the like there's the fruits and veggies that are really only available in some areas. You know, like what? Dorian. Dorian is one that I don't ever see in North America. I don't think I've ever seen it in North America. In part because like if you know anything about it, you probably aren't going to ship it on a plane or via normal shipping methods. So it tends to be a thing that's local. So you get that like I honestly don't know if Dorian is a like is that the English word for it? Or is that actually what it's called? And I honestly don't even know where it originates. But you know, like it's that sort of situation where there's fruits and veggies that are specific to regions. So then they don't necessarily have a representation in every language because it's, you know, if an area doesn't eat it or ever have it or see it, they don't tend to have a word for it. So then you end up using the word of the wherever it tends to grow. Okay, so we have this root function render. This would be more like a render HTML. We might actually want to look at potentially renaming that. We also have this impl. When we use the impl, I think I still have there's a generated piece out here. We get all right, what's our parser? Parser is what we have it called. Parser class. So it generates a parser for us. It's got a bunch of like internal private bits and such. But also like, so like destroy into raw, free, those are not, like those aren't top level. We don't have those written here, but like just part of like it going across a language, as in like going from WASM to JavaScript, or otherwise Rust to WASM and WASM to JavaScript. You need these like internal functions because it cares about being able to free memory. It doesn't work the way JavaScript works. So these are all on the impl. Parse render, parseful. Those are all on the impl. So those, like we could export this. We might get some of this information. We might want to like change the name or address or change how these are set. So I think potentially what we want to look to do is that we have a single function render. It doesn't look like that's wired up to export from WASM bindgen. We have an impl parser, which is wired up to generate a thing from WASM bindgen. And I suspect what we might want to look at doing is actually only exporting functions. We potentially do need something like this, where we like set up this root level like Cooklang parser. But the actual functions and such off of that, we might want to see if we can keep this implementation a little bit smaller or lower level. Split keyboard, yeah. Hey Gabriel, good to see you. I saw you jumped in the Discord. I enjoy it, honestly. I had been interested for a long time. They're not cheap, especially depending on which one you get. I had been interested, but not enough to like spend the money. And then I started having like a back shoulder pain, and it seemed in part due to how I was like posture and how I was sitting. Hi, yes, kitty. So I was like, you know what? I think it's time, and I got one. I do actually really love it, and I use it. I have a. Can I see the layers? Smart layers, heat map layers. Hi, kitty. Can I? Let's see. What if I click at it? Will it? Yeah, here. Well, this is my layout. Hi, cat. This is what I got. This is my layout. It is a ZSA. They have this software called Orcs, which allows you to configure it, multiple layers, etc., etc. They also have this app that comes with it. If you're using Windows, I think there's a requirement to have the app installed. I don't know. It might be a requirement to have it running too. But also I kind of just leave it up because it's interesting to talk about, and folks jump in and talk about it. So but also there's a couple of those, like I'm like 80-90% there, and there's a couple of those like multiple key type shortcuts which I haven't memorized on this layout yet. So yeah, it's I use it for both work and for just streaming or at my computer or whatever. And then I have this one too, which has Bluetooth, and it will work with that's a Keychron K6, I believe, if I recall correctly. But that is Bluetooth. So I will, whatever computer I'm like using as my secondary, or that's I tend to have both computers on at my desk, and whichever one that I'm not focusing on, I have that keyboard hooked up to it. So I can, like, if I need to type a message or something like that, I have a keyboard and I don't have to switch hard wires. So whichever one I'm like actively working on, I will use this keyboard. All right. So I think we potentially want to see if we can lift this out into like pure functions. If not, honestly, a constructor doing a new other constructor might still be fine enough. Because there's this idea of extensions and changing the extensions. We probably want to be able to support that. And some of this all might be very much tied to the fact that it needs to have a Cooklang parse renew. It is, with this, it is very convenient to have it in an impl. But either way, I think what we do right now, we have in index.ts. We are currently just exporting basically these like top level pieces that we're expecting to support. In theory, we could export everything, but I suspect we're going to change things around. Like, things in here might move around a little bit. This is basically just like re-exporting stuff. I don't want to just like blindly export everything and then like if people start relying on it, even though it technically hasn't been released, breaking changes aren't nice. So just export the stuff that like we feel pretty good about right now, and then go from there. But in this case, what we're going to end up having is something like a we could almost just do an export of the how do we go about that? So if we root index.ts, I mean, we could just write it all in here, but I imagine that the implementation is going to end up getting rather large. So if we go and say, let's play around with this idea. We have a, I guess we'll say parser.ts. We can import the same bits and export these. We need to, though, instead go up a extra folder level, and then we want to go into index.ts, and we're going to instead do an export star, I guess. Let's start with this as an idea. So this is like our top level barrel file, and then we can do stuff in source. We're doing this makes sense because we are only exporting a couple items here. We're not just blindly re-exporting everything. But at the same time, I'm not terribly keen on using this in part just because I feel like folks tend to like copy and paste that and just use that pattern everywhere. And having all these barrel files usually isn't the best idea for, I mean, that's a whole rabbit hole. All right. I think we've kind of got, we'll check this off. We've sort of like looked at the WASM bits. We're getting to this foundation here. I think we take this parser and we're going to do export const. We can either do a class or we can just do like a pure object. Let's peek at that for a hot minute here. So at this point, classes are pretty widely available. It is it's a template for creating objects. We can effectively do the same thing with an object. So before classes were like a top level thing that were implemented, folks were doing using functions as constructors. So you'd have this like like this kind of stuff where you like have a name for a thing and then you like add a bunch of functions to it and you have to like call in a init. So you do like a rather than doing new parser, you would instead say like parser.init. Functionally, when you end up using it, it's probably going to feel very much the same either way. You'll have to look at the docs to see how to implement it in either case. I feel like constructor probably is fine in part because it feels very like Rust-like, I guess. The nice thing about having a class is it's easy to like tie specific values to it. So you can have a class and you can do like this kind of stuff where, if you only have a constructor, it's not much different from a factory function. So you can have a factory function that creates like plain objects. We can have that. There's probably like 3-ish ways that we could go about using this, or maybe 2. If you have a recipe, it'll start as a string. You can potentially just say parse this string and return the recipe. More in the idea of like a functional program type thing. So like you have a function that takes input, and then it returns output. Very straightforward. We could do that, but in either case, we're still going to have to initialize the WASM bit. So there's still going to be some expectation to have like a new parser. So if you're spinning up an instance of this thing, I mean, I don't know that I necessarily want the instance to be tied to WASM being initialized. But it is if you're gonna have to call like a new parser anyways, it's nice to just tie all the WASM bits in there. So then you don't have to tell somebody to initialize it and then use it. Okay. Let's look at the playground. The playground is also in this repo. It is actually using technically the TypeScript version of this. We're just doing like a local build and then like copying and pasting it over effectively. It is vanilla.js. So we got a top level run, debounce helper function, util type thing, and it's just running at the end. So it's using Ace editor and some like vanilla JS type ways to like get information about the inputs, blah, blah, blah. The core of it though is on this, so we have some event listeners. This handles changes. Wiring up extensions. You can change up at the top of the playground. Up at the top of the playground, there is this stuff up here. So you can change extensions. But most of the functionality that we end up having is in the parse. So we have this function parse. We need to first do, in this case, we're calling new parser, right? And then we're calling parser.parse. Yeah, so in this case, what we're doing is we're just straight up giving it a thing, an input, and then it returns a value. But all we're doing here is just logging it out for like testing purposes, basically. Then on that parser, we still have other functionality that we can do. Parse ASD, parse full, parse render. This is all like very functional. Did they move the init? I had like a little to do to move the init. I don't see it. That would be kind of cool. Because we're not specifically exporting it, right? We're doing version and parser. Version parser. We have a self load set. Oh, interesting. So this is the other bit that's interesting about WASM is you need to initialize it. So you can, JavaScript, you can basically just give in HTML file a script when your browser is rendering it. When it hits a script, it will parse the JavaScript and then begin to execute it. So depending on how you load it, et cetera, it will run the JavaScript. WASM, you need to initialize. So there's some like concept of loading it. And if we look at like the package here, this is doing this jazz. So we have the actual WASM file, which is the thing that contains basically like the Rust internal code. And it's doing this wbindgen start. So that would be WASM bindgen. And this is initializing it. So I think with our current settings, it just automatically initializes, which is kind of nice. So if we call new parser, we can just use it straight away from here, which is kind of handy. So I think we want a constructor either way. I think we go with a class, because if we have a constructor, we can potentially, if we need to do anything with WASM, deal with async loading. Every system is going to end up loading WASM in its own way. Like if you're running in Node, it's going to potentially load that WASM or need to load that WASM in a different way. So if you look at the WASM pack configuration, they've got like 4 or 5 different ways you can bundle it. In this case, in the playground, we're relying more so on Vite and this specific WASM plugin to actually do the initialization of it. So we don't even need to do the initialization. So I'm guessing that we don't have a build in this, but if you do the, yeah, it's calling Vite build. It basically bundles in and initializes that WASM for us. I'm pretty certain. But if we need to do or check to make sure that it's initialized, we could potentially do like a, give me the version number. If the version number throws an error, then we know it's not initialized. We need to initialize. So if we need to do any of that type of work, having a constructor do that may be convenient. So that being said, I think we still go with a class because at like a language level, we're sort of enforcing this need to do a new. And then we can add these methods. And once we have like an instance of a new parser, let's see, where do we go? I guess we look at the playground here. Once we have an instance of this parser, we can then call that's kind of interesting. Giving it that function that way. We can basically just give it an input. So as long as we have an input, and we might want to like tweak what the actual inputs are here. But as long as you have an input, you can just give it the input and it's very functional. So once you have a new parser, you can just like throw things at it to parse, which can work nice. The alternative is that we say, do like new parser and give it a string or a recipe right away. And it sets it internally in the, this recipe or this, content or raw or whatever as like an internal property. And then if you don't do, like if you say parser.parse, if you already have a recipe, you don't need to give it an input. So then that instance is tied to a specific recipe. So I think there's probably or potentially a reason to support both ways. And that is in part why I think we could do a class. So if we say parser, we're going to do import parser as we'll say Rust parser. And so we're going to say class parser. This is going to be a little bit funky because what we want to do is say keep the old version. So we're going to export parser. This, and we're going to rename it to the old one. And export, how can we do this? It's not terribly convenient to do it that way, is it? So let's say const parser, parser equals Rust parser, and we'll say for temporary backwards compatibility, let's export it with the old name. And this is going to be I don't really want to, I guess we'll just say new parser, and then we'll rename it later. Or maybe we say recipe parser. We could always rename it, I guess. And then we'll say export recipe parser. So now we have this, and we can say constructor, and we don't really need to do too much work though. But I think we say we can expect an input. So if you say new parser and you give it a string from the get-go, you have created an instance of the parser with a recipe already set. So if we say do, I guess we'll say options, and we'll say recipe parser options. You know what? We're not going to deal with options yet. We're going to say content. We'll say, what is it? Private. I guess we can make it public. Public. Maybe we say raw. Public raw string. So this will set it as a this. So if we have a method like to let's see, get, we'll make a getter which does get raw. I don't know if I like that naming, but then we can just say return this.raw. So now anywhere within this class we can do a this.raw, and we will have it if it is available. But we also want to support it being undefined. So now in this case, we have a recipe parser.raw, and that's either string or undefined. So if we have if we're given it, it will set it. Otherwise, we want to say set raw. I mean, do we do that? I think we rely purely on the instance. So then what we end up doing here is we say if we have raw, then we always run functions and do the parse based off of that. So at the moment we would potentially have to like pull in the Rust parser and do like instantiate the class for the old like direct implementation, like the impl. If we wanted to wire it up, but I'm not going to worry too much about that right now because I want to get a couple tests in place. Get a couple tests in place and go through our like to-do list of stuff we want to actually return or have this do. A bunch of which we've already implemented, but we potentially need to just shift things around a little bit and see if we can get away from doing that impl directly. And I guess maybe a quick check on that is we have this Cooklang parser, which is in a struct, and that struct is WASM bindgen along with an impl for said struct. That parser returns. I don't know how this ends up looking in the actual implementation. Maybe a quick check on that though. If we have, like I'm looking at code that I generated on my machine. Things have potentially changed, and and I just want to make sure that what I'm looking at is still current. So it's using wire it. I mean, honestly, I set this up. I've never personally set it up before, but after going through the work of setting it up, honestly, I'm not, for this use case, I'm not huge into it. I'm not like hugely into it. So you would use it via something like this, wire it. I don't have a build command. Playground, watch WASM. I don't have a top level build command. Huh, okay. So if I go then instead into cd TypeScript, whoop, and we do npm run build WASM, I guess. I just want to make sure that what is built and what I'm looking at is still current. Because things have changed a little bit. I just want to make sure that whatever I'm looking at is still, because like I'm not the only one working on this. All right, so we have export version, export function version. Encode string, pass string to WASM. Yeah, so like if we just did export star, you'd end up getting, well, I guess those are just, those aren't exported. So you wouldn't get a whole ton of, you get this like WBG. I guess you do get some bits directly store export was okay, you would. Like you'd get this WBG set WASM from like in the public API, which I don't think is wholly appropriate. I suppose we could do this. Like I don't hate this. There's a getter and a setter. I don't hate that. So if we do like get raw and do a set raw. I guess we could just say raw. And then this does a this dot raw equals string equals raw and duplicate identifier. That makes sense. We'll say a raw content. So we are doing this, something like that. Return raw content. Yeah, so this has to return something. So if this dot raw content is not defined, then we want to throw an error. Whoop. Throw new error, content not set. Recipe not set. I suppose I could do maybe just do a call dot raw content to set it first. Sure, so that'll be enough. So I don't think we want to just re-export everything. I think having even just a top level thing that handles like makes the API a little bit nicer to use. You can do this raw, or you can just ignore it and go purely functional. And then like the purely functional implementation would be kind of how we have it set up in the playground, which I think it makes sense to continue to support it. In the playground, it makes sense to keep it this way. I don't see a reason to have an instance of it because the content is changing dynamically. So it feels, or in my mind, it makes sense to keep it pure, like pretty functional. String changes, give string to function, function takes input, returns output. We render output. That's pretty straightforward. But these functions here, we'll want to likely re-implement them. So we have this like recipe parser, which will potentially keep that same type. But what I want to then do is go to our tests. We have a types test. This is mostly just like checking to make sure that our type is kind of working. There's like, this is like a nested type. It's not just a top level like object looking type or like a record. This is just going to check that it's actually returning it as that type. So like if this internal bits within this type break, this isn't going to catch it, but it's something, it's a start. So what we're going to do is we're going to say, I think we just do a parser.test.ts and we just have a top level thing and we do we're using vtest on this, right? Yeah. So I think I do an import describe and it from vtest and do we're going to start with the top level describe block because we kind of have these two entry points I think that we want to check. We want to do like it. Well, here we'll do an int it dot to do things. All right, so our top level sort of two entry points are create and use instance, and then the other one is functional. So functional would be you don't set a string or you don't set the content, you just call the parse function. In both cases, you still do need to initialize it. But here we can just say const parser equals recipe parser. And it is a class, so we do need to call new. And now here we can do a we don't have the functions to do it yet, so it's going to fail. But we can say full parse of recipe string. I don't think we need asynchronicity in this, but from here we should be able to do a parsed recipe equals parser dot parse. We'll say recipe, and we'll say expect parsed recipe to equal, we'll just call it a string for right now. All of this is going to fail. And we'll say, we'll just make a top level recipe of, hello. We need a string. We'll just get things rendering, and this, I guess in this case, it is still actually going to equal hello. Now let's run our tests. We are editing a single JavaScript file. So at the moment, we won't actually need to rebuild or regenerate that WASM file to otherwise update and have the test handle the new things we've done. Let's do an npm run. Npm run is nice because it just lists out the scripts. So we can do an npm, I guess just npm test, right? This should run vite in watch mode. Yep. So we have our type test that is working. And we have our parser. We have the top level create and use instance. Our things is to do. So it is skipping it. And this one fails. And that's expected because there is no parse. So let's start to look at that. I think there's going to be a constructor. We'll find out, I guess. We have a getter and a setter on raw. I think we end up doing a parse. And this will be a so if this so if we say if this dot raw content, well, here actually let's do it this way. We'll say recipe string question mark string, and we'll say if recipe dot string. No, actually I want to use this. So if you have it set, just return that. So we'll say if this dot raw content, so if recipe string is set, we want to throw new error. We don't want them passing a recipe string if we have a raw content set. We'll say recipe already set, create a new instance. And then we can do a return this dot raw content. And we do actually need to do the work. So we'll say to do parse this, then return. And so if raw content is set, otherwise, well, I suppose we can do this. We don't need to. We can say if I suppose we can say if no recipe string, if no recipe string, then throw new error. And how do we explain this? I guess pass a recipe as a string or generate a new instance. We'll probably want to like work on those error messages, but so in this case, we're going to return a recipe, return recipe string. Okay. So we need to where does that come from? That's from vtest too, right? Yep. I don't know why it does that. If I tab complete, it sometimes like inserts it and updates the import statement. It feels like a bug, but you know, whatever. All right. So this is doing the parse. Let us go through, we'll update our tests to handle all the things that we care about. And that means going to our issues, and I created this one. This is based off of sort of what we've been chatting about. There's been a little bit of chatter in the actual issues, but most of it's been in the Discord. If you're interested in getting involved, hop in the Discord. There's a, I know for sure there's a link. I thought there was a link here. I guess there's not a link here. There's not a link here either. Interesting. There is on the root org, there's a link to the Discord server. If you're interested in getting involved or using the project and you do Discord, if Discord is your speed, feel free to drop in. So we made this. Basically, if we go through all these sub issues, then we're probably at that at a place where we can actually move forward and release. So include debug and version information, metadata, HTML, CSS. The CSS is potentially up for consideration, but parse, and I'm not sure what document ensured, but and then we have a couple like things to make sure stuff is working as expected. So the first one would be include debug and version information. So here we can say a private. No, this will actually be a public get. Public version is string. No, public. What is this? Public. Why can I not remember? I guess technically it can be undefined. I wonder if I set it in the constructor, if it'll be happy. This dot version equals, yeah, okay, cool. So this we should be able to say version and call it right away. So now we have something to do in this overall recipe parser. We're going to do a top level test here, and we'll say it returns version number, and we'll say I think I need a new hotkey for my equals. I always trouble. Oh my goodness, this equals and I guess greater than symbol. I always struggle typing that. That might be one of those things I need to tweak on my keyboard settings to make it nicer. So we say const parser equals new parse recipe parser, and we do a expect parser dot version to be defined. Cool. Now so what's nice about this is it ends up being a getter. So you can call it parser.version. You don't have to call the functional version of it, and then it ends up being set within it. So like as we initialize it, it just captures that, which is a little bit nicer in as far as like JavaScript. It feeling like JavaScript and not a generated thing. There's also debug information. We might potentially want to include some of that, but that might make sense on like an AST. So we'll end up basically everything in the Cooklang playground. We're probably going to want to represent that as well. So we have what's the document? Oh, and document, as in like write documentation. So get set raw, get raw, parse. We could potentially pull this out into like a little private method that does the same stuff every time. I'm tempted to do that. Let's do it real quick. So we can say private. That'll give us a method that we can use only in this class, and it won't be, you technically can't use it in the consumer API version of it. But we'll do private. We'll say instance versus handle functional and no, handle functional or instance. And this is going to take we have this, so it's going to take an input. So we'll say instance input, which is going to be a string or undefined, and then it's going to be a and then like the function that we end up running on it, right? I guess we can just return. Because that's all we're actually doing right now. So we'll take an instance input, and we'll take in yeah, because we're always going to be operating on raw. So the input will always potentially be raw. So the instance input is just going to be basically like this. So then if we go like this, we can say that. Change all of these. And then I'm going to take off this parse then return. And here we can say, instead do a const input equals this dot handle function or instance, and we're going to give it a recipe. Why are you complaining at me? Oh, I got an extra opening thing here. Okay, recipe string, this, and return input. There we go. So now we got this little helper function that will always handle these, like, is it an instance or is it not? Do we use the raw content? Do we not? So this is all just handling of it being an instance of a thing or a more functional approach. So now in all of our cases, we can do a parse and then get the input and then do whatever function we need to. So we need a parse. We need a metadata. So we'll do metadata, and I guess it's always going to have this sort of style. So we can do this, and we'll do metadata. lightly opinionated HTML and CSS. So we potentially might need to do some CSS to make it look nice. If we look here and we go to our, so render, I think is the HTML version. This is rendering a recipe in a format that renders well in the browser. Well, here, right, full parse, events. I don't know what the difference between full parse and events is. We'll have to double check on that. AST is similar to a full parse. But gives you like the internal bits within, so you have an item and there's the text, there's an ingredients, and then there's the text. Whereas you look at the full parse and you just have like sections, ingredients. So they're structured slightly differently. EST is going to be more for debug. So that might be a thing that we can like nest under a debug helper or something. Standard metadata is like your YAML front matter. If you have worked with Markdown, Markdown tends to have it's not inherent to Markdown rendering, but it's pretty common to put like a block of YAML at the top of a Markdown file. And then that gives metadata to that file. Same sort of idea here. And then the render. So there's going to be like a render as in like render a string. There's going to be render as in like just return the content itself. And then there's going to be a render as in like HTML, I think. So let's put I want a recipe. Let's grab a test data, recipes, contrived eggs. Okay, so like here, a little bit bigger of a recipe. Here you can see the metadata. These are the steps. They get broken down to ingredients, numbered steps, and then the metadata. So the render is like make it look pretty in HTML. Full parse gives you the full parse, but also like this isn't terribly convenient to use in JavaScript. It works, but we might want to like pipe some of that stuff into a map or something like that to make it a little bit more convenient. So like, and then there's also this something's going on weird there. Y'all see that? Full parse, render, AST. AST is not updating if, oh, is AST throwing an error? Yeah, unreachable. Okay, so we have potentially a bug in the playground at the moment. All right, so we have a parse, we have a metadata. We have a, like if you want to get the raw, you can do that. If you want, so I think we return a, maybe we say render HTML. Does that feel right? Render HTML for a name. We could potentially also look at what we set for previous names. But we can do, I guess I just need to copy this every time, right? So render HTML. Render pretty string. That feels fine. We'll go with it. And then we have a render. So we have metadata, render HTML, render pretty string, a parse. I'm going to move the metadata. The metadata feels nicer above the parse for some reason. But like these are human readable things in some way. The parse we might end up wanting to think about depending on how we structure data. And then, so I handle parse, HTML, CSS. The HTML, CSS, I don't remember if it doesn't say anything about a string. So we might actually need another issue to represent the render pretty string. We might need to come back to that. The render HTML is more like returns something that is like gives you like a base level thing to work off of. So I mean, theoretically, we could potentially do that. I guess I don't want to get too in the weeds about the implementation of it yet. But like render HTML would be like give some H1s and P tags, and you can always give your own CSS for it, or potentially we give a CSS file or something like that. I imagine if we just use a bunch of HTML tags, it's gonna, as a base level piece, just render reasonably nice. And then if anybody using this wants to do more with it, then they can do that. But this would, rather than require them to like pipe into Markdown and then render the Markdown as HTML, or pipe into like a JavaScript object and then dump that all into components to actually render. You could, in theory, just render the HTML or return the HTML directly as a string and then rely on your existing CSS to make it look nice. So I think we do render HTML, we do render pretty string. And what's our handle parse? So there is potentially this like to.json. So once we have a parse, we could potentially do, parsing it is useful. And I think metadata makes sense. But like the internal bits of that, we might want to do something with that. And I think that's likely going to be the last parts that we talk about. What's on our to-do list? Our stretch goal is the WASM pack and car goal. I think we leave maybe 5-10 minutes for that. And then we'll come back to where we can hopefully come to that. But I want to dig into a little bit the idea of, if we have like a full parse, how do you use this? Like, how do you actually want to use this? And how do you want to take that content and then potentially render it? I mean, extensions and load units might, like, we potentially need to do something with that too. Let me add that in there before we forget. Here, I'm also going to do a couple of to-dos in here. I'm not going to push this up immediately. This will probably happen hopefully sometime today. But to do create issue for this. We have a metadata. We need a I guess there's almost going to be like a getter and a setter for extensions too, right? Some of this can potentially just extend what we have. So I guess extensions get, so this will return, and I think extensions is going to end up being a we potentially have an options here. And we might want to do like overload the constructor. But let's do, for the moment, we'll say public. I guess we don't want to do a getter and a setter, do we? Okay, well, maybe we do. We'll do extensions. I don't remember what extensions looks like. So we're going to just, at the moment, hard code it effectively to an array of strings, and we'll come back and fill that in. We'll say this as string this, extensions. So it is defined. Why are you complaining? Duplicate identifier. Yeah. Okay, that makes sense. Suppose we just do extension list. Sure. Extension list. Extensions, and this is going to be that. Return this. Okay. To do create issue to fill this in. Okay. So I think we need to look at the idea of, where'd makers go? Do we do maps for some of this? Like we're going to have an ingredients new map. So like if we have an instance, we could potentially do like return properties for ingredients and have that return as a map. I guess a map or a set potentially. Let's double check though. The debug stuff. Yeah. So if we do a debug, there's going to be a version. So actually, I think we want to put the version number on debug. So we have, I guess let's do that right now. So we'll instead switch this to be a debug record. I don't, what are we going to put in this? I guess it's mostly going to be strings, right? String. So this would be like, if you're having issues, actually let's do debug info. Parser, recipe parser, recipe parser debug info. That feels fine. And then here, this is going to be a type, and we're going to say equals, and it's going to have a version of string. So we have this. It has no initializer. So we'll say this dot debug equals this, and then debug dot version. So this dot debug version is missing in type. Okay, yep, that makes sense. So we'll do one of these because it has to be set. That is what that error is telling us. We have defined it as a thing that has to be defined. It cannot be undefined, so we need to set it immediately when we initialize this, which is fine. Now, We want some information here that is going to be like debug like. So if we look at the playground, we're going to open up a main.ts for the playground. We have a parse full. We have the parse events. I'm not events. I'm guessing that's just like similar to the AST. So I think what we end up doing is we say this will have a AST, which is going to be a, we can make the AST a string, or we can make the AST an actual like JS object. I think we potentially want to do a string because it's going to be the AST like representation from Rust. I don't see a use case where somebody's going to need an AST and then use that AST to then walk a tree to do their own like different parsing. Like if you're going to do that, you're probably going to want to do that in Rust. So I think the AST is going to be mostly a debug for debug purposes here, in which case a string I think is going to be fine. If we go back here, what is our AST? Parse AST is returning a string. I think that's going to be fine. I think we say the same for events. Events is a string. Yeah. We're gonna put those as question marks for the moment. I think we end up doing those as getter and setters though. So actually, I guess not. That could just be a method. And it'll be the same as these. So you'll end up having a method. So if we do a method for so we'll say public. I guess it's like debug, right? So this dot, yeah, we'd be like replacing this. Interesting. All right, we're gonna put to do here. To do convert this into a method to return all properties. I think if we want the maybe we do version as separate. Like I think I can see that. So debug, we're taking you out. We're gonna have a top level this. We'll say a public version equals string. We'll always set it. Okay. And we're just going to do that for right now. Okay, so in our tests, we need there's going to be functional. I guess the debug would potentially be implemented in both. Okay, so we have a AST, we have events, we have a full parse, we have a render, and a standard metadata. Now the render in this case, I think is just HTML. Our full parse has a checkbox for JSON output. So I think the last bit here is the if we call a parse, if we call a parse, we want to potentially do some like returning of an ingredient or returning of, like we could potentially do like recipe.ingredients, and that returns a map. That feels reasonable. So if we do a parse and we have an instance, we can include some additional properties. So if we have a, we sort of do that with metadata already. Like if you call the functional version of this, it'll give you the metadata straight up just returned. We could do the same for ingredients, because top level full parse, and the full parse does a parser.parse. Full does a parse full. So we have a parser.parse and we have a parser.full parse. Functionally, we do a there's a parse and there's a parse full. So this parse full does Saturday JSON. This is the piece that we've worked a little bit on stream, and this is actually going to return like a sort of typed version of it. So like in realities, these are kind of doing the same thing. So I think our parse full ends up getting like replaced with this parse. Functionally, they end up doing the same thing, but this parse will return an actual like typed thing. So if we do that, our parse will return, in this case, it's returning a string. So here, to do return fully typed JS, I mean, it's basically a JS object, right? And if we have an instance, we could call parse on that, and then it returns and sets the other variables. So if we call metadata, it's going to potentially throw an error. So like in the same case, we can do a an ingredients. We have metadata, we have sections, we have ingredients. And then we have a couple other little pieces here. The sections is the like steps. So maybe we call, we do a metadata, ingredients, steps. We have cookware, timer, inline quantities, and data. So data is servings. Okay. So it's got 2 servings. I don't know how we represent data. We might just want to put a to-do for that. Okay, now if we reorder this just a smidge, we have sort of this top. Let's reorder it and say there's this top level pretty string, top level render HTML, and then we kind of have this like top level parse. This top level parse will take a recipe string and return the parsed version of it. But once, like if we generate an instance of it already, if we have an instance and we call parse on it, now these should be set, or we could like reference or otherwise grab those separately. Now, technically that would end up parsing each one of these separate, in which case we would also potentially want to set some like recipe instance information. So we have a raw. And if we do a private recipe instance, and we do a type recipe instance as this will be a metadata. I'm going to just any type these for right now because we're running short on time here, but steps, ingredients, and we're going to end up basically having all of these ingredients, steps, metadata. That'll be fine for right now. Now, recipe instance is going to be one of these, or it can be undefined. So if we call a parse, so we'll say if is instance, then we do a thing. So if it is an instance, then we do to do set this dot recipe instance content. And we here do a private is instance, and this will be a if this dot raw content return true, return I guess we just do a this. We'll do a no, not this, but this. So this will make it a Boolean is instance. There you go. I guess I can make it a getter, right? Private get instance. Okay. So if it is an instance, then we set the content for these, and then we do return an input. So that would then allow us to do, if it's an instance, we can just return the data. You're only ever going to call parse when you want to update the content. So I think this is fine. But here we would then instead say, if it is an instance, to do return this dot instance content. And then we can do basically avoid parsing. If it's already set, we can just avoid parsing. And now that should give us a thing that's passing here. So create and use instances. and the functional version returns full parse of recipe string. So that gives us this. Then we could say so this is going to be the functional version. So we can say it returns ingredients list. And that will be one of these. Whoop, every time. Basically one of these again. But instead of doing a parse, we instead call ingredients, which should still give us hello. And again, we'll have to update the content. So these are actually like reasonable tests. So we'll probably want to throw in an actual like recipe here that we can use for content. And potentially we could do like fuzz testing stuff here, but like the parser is going to be the thing that handles most of it. So we just want to like make sure that it's like rendering the appropriate thing. So some sort of signature to indicate that it is HTML if we're trying to render HTML. That would be enough. We don't have to like dive into it too deep, I don't think. I think this is going to be good. I think this will like there's enough here in the class that we have a bit of a foundation. And then we'll have to do a little bit of wiring. So I might do a little bit of wiring just to make sure that it's going to work as we expect it to. And what we have should give us all the pieces we have here to ensure that the playground continues to render as need be. If we haven't missed anything, it should still be able to handle everything. And we handle both instances. So like generate a new instance of this recipe. I guess we could also consider it doing like a new. No. We don't need more features at the moment. Ship the thing and then we can worry about further features. I think this is going to give us options where we can do instances or we can do just straight up functional parsing. And the instance would be a case where you want to like handle these things disparately. And like render them all separately. Words to live by, right? I think this will give us like the best performance for whichever use case you end up needing to do. Because if we relied purely on functional and you wanted each one of these pieces of data in a disparate manner, it means you'd have to call parse potentially 4 or 5 times per recipe. In that case, I probably would say you create an instance, and then from that instance, you can grab each one of these things that have already been parsed and just have been like set as like in memory for that specific instance. Okay, and then I'll probably write a couple more tests just to like get sort of the framework that we end up filling in here, and I guess the only remaining to do would be like should we handle these as like I think a map could potentially make sense. Steps are going to be like in order, so I don't know that they make sense. Like this could be like an array, and that would be sufficient. And if we look at the full parse, each one of these ingredients is coming in, and it's an ingredient with related information and relations. So like we could potentially wire up the relations to work with a map. Because there's like some circular reference type stuff here that we could potentially do. And if we have the relation, I don't know that it makes sense for every person to wire up and do other relation type stuff if they want that information. We can add a couple helpers in here right at once, and then everybody gets a benefit from that. But sections is the steps. Add a bunch of stuff. Oh yeah, yep. Steps is the like section is the steps, and yeah, yep. I think this is good. That could potentially be a map. I suspect the other bits could potentially be an array with maybe a different format. And then so some of the like TypeScript information that we would want to pull out of like the Rust generated thing will be maybe the internal bits. So the thing that represents the metadata, rather than like this fully typed thing which needs to match the exact same structure that's coming out of the simple right now. So I think if we can get away from doing the impl and just export pure functions, like this one is exporting HTML, I think that'll be a little bit easier to handle the TypeScript and ensure that the TypeScript doesn't break via Rust. So like when we do like a Rust, like a cargo check, if we can get it so that it doesn't, that cargo check also ensures that our TypeScript's not going to break, that would be great. Because otherwise, like with the current setup, we're just exporting this top level scaled recipe with report. It's in a place where it could potentially break, and we could write a whole bunch of tests like this to ensure that it isn't. But then those are also going to break if we just change the type signature, which doesn't feel great either. I think this will give us good foundation. I'm going to button a little bit of this up, and we will go ahead and open it up as a PR, discuss a little bit, and we'll see where it goes. Next week, we'll do some Tory Docs stuff again. It's our end of the month, so we'll do some Tory Docs. Have a great rest of your week, everybody. Happy Tuesday. See you next week. Bye.